I'm Anil Kumar. Welcome to my series on algebraic identities. We'll look into x plus a times x plus b. So in this particular video, we are going to explore the product x plus a times x plus b. We'll also see this relation with area of a rectangle. So that is kind of a modeling of this product. And then we'll pick up a sum and product form of this particular equation and then have some practice examples. We'll also explore what happens when b is equal to a and when b is equal to minus a, or if b is something else but with a negative sign. Correct? In addition to this, we'll have few interesting questions for you to do. So let me write down some questions for you to practice. So you have questions like expand the following. So we could have x plus half. We'll introduce fractions to you times x plus 3 by 4. So you could practice questions like this. You could also do what is a plus b plus c square equal to, right? So you could have practice question kind of like this. And what will be x plus 5 times x minus 5, correct? This is when I'm writing b as minus value of something, right? C, right? Minus 5 plus 5, right? So a value is 5, then b is minus 5. That is what I'm trying to say. So these could be some examples which you could practice. Okay, let's begin and see what is this product x plus a times x plus b. So we have this x plus a times x plus b. We'll use a property which is called distributive property. So that really means that when you are multiplying a binomial by a binomial, so these are two binomials, right? So we are writing product of binomials. What are binomials? Binomials have two terms. Let me write down that also. Binomials means polynomials with two terms. Okay, so that's what we have. So when you multiply them, we'll apply the distributive property. That means x should be multiplied with x plus b, and then plus a will be multiplied by x plus b. So that is how you distribute. So we have applied the first one, which is the distributive property here, right? Now you have learned already how to multiply with monomials, so we'll apply that. Now again you could distribute, so x gets multiplied with x and also with b. Similarly, a will be multiplied with x and also with b. So what you get here is x times x is x squared plus x times b. We prefer to write bx. xb is also correct. But we prefer to write bx. We always write that variable later. We are assuming x is the only variable in this case. In this case, we get ax plus a times b. Now, if you look into these two terms right in the center, these are like terms. So, like terms can be combined. If you combine these terms, what do we get? X squared plus, since x is common, you could write this as b plus a times x plus ab. Do you see that part? Now this is kind of reverse of distributive property, correct? So we factored this. So this property here is reverse of distributive property, right? So we just did reverse operation, right? you call it factored form. So we call this factoring. We'll actually get into details of factoring later, but that is the basic concept. So what you observe here is that here you have a trinomial. So what we have, here we have three terms. This is a trinomial, right? Now in this trinomial, you get three different parts where these constants a and b are written as product and as sum. Do you see that? So this part here is the product and this part here is the sum. So sum and product of these terms, the ones which are not the variable, the constants associated, is that if I give a value to a and b, then we could straight away write the answer using sum as coefficient of x and product as the third term, which is a constant, right? So if a and b are constants, real numbers, then what happens? Then see, let's take up some examples now. For example, if I have x plus 3 times x plus 2, what should you get? Well, the first term is x squared, right? The second term will be x with product of, no, sum of these two numbers, which is 5, right? And the last term is the product, 3 times 2, 6. Do you understand? So that is the identity. So what we get here is that if I have x plus a times x plus b, then what I get here is x squared plus sum of a and b times x plus product of a and b. Do you understand? So that becomes an identity. So if I have something like this, for example, x plus 5 times x plus, let's say 7, then the result should be x squared plus add these two. We get 12. X plus 7 times 5, 35. Does it make sense to you? Correct? So this is a very important conclusion. So what you get here is sum and product as I have written right there. Now we are going to explore this in this particular video. So let's take some more examples based on the same thing. Now we'll talk about a relation with rectangle. So what I'm trying to say here is, we'll again take up this x plus a times x plus b. Now we saw that this is equal to x squared plus a plus b times x plus their product ab, right? Now you can think about a rectangle whose sides are, let's say, let me draw a rectangle here. Okay, so let us say this is our rectangle whose sides are, let's say this side is, let me draw a line here, and let us say this is x and this is a. So one side is x plus a. On the other hand, let's say we have this big x, so let's say this is the other side, which is, we have x here and b there. So it is x plus b. So what you get here is rectangles, and you can find their area. What is the area of this space? The area right here is x squared, x times x, right? These two sides are equal. That is a perfect square, x squared. Now on the other hand, the rectangle shown here is x times a, so it is ax. The rectangle shown here is b times x, so it is bx. How about that area? This area is a, this is a, right? A times b, so it is ab. So what you notice in this particular case is that we could actually write this identity as x square plus sum of these two. That is to say, sum of these two. They both are like terms. They have x as a common factor. So, a plus b times x plus the third term, which is their product a and b. Don't you see these are equal? So from a rectangle, we can easily get to understand this concept, correct? So it is to say that sometimes if I have a rectangle like this, let me draw another rectangle here, right? So I'm making a smaller one this time, okay. And if I divide this rectangle like this, and I have this kind of like this, and these are lines like this, 1, 2, 3 and 4. Then I could write this rectangle as, this is x, this is 1 unit. On this side I have x, 1, 2, 3, 4 units, so x plus 4. Do you see that? So the area of the whole will be x plus 1 times x plus 4, which will be equal to x square plus, add these two, 5x, plus multiply 1 and 4 to get 4. Correct? So this 4, when we multiply, so we get that 1 unit, which is 4. 4 times 1. X square, so let's color. So we have this as x square. Clear? So we get this term as x square. Now can you tell me which are the 5 x's? So 5x are, we have 1, 2, 3, 4. Is that okay? So these are 4 and this fifth one. So we have these 5 x's. Do you see that? 1 times x. So we have these 5 x's. So that becomes 5x. And 4 squares you could always identify. Which are these? Correct? Do you see that part? So you could have a model which gives you the area of the whole thing. So x plus a times x plus b could be represented as two sides of rectangle. Correct? So as you can find area of a rectangle or side lengths of the rectangle using this particular concept. So I hope this is clear, right? So let's move on and take something else. Now this says sum and product form. We have already discussed sum and product form. So what we know here is that x plus a times x plus b is equal to square of x plus sum. So that means a plus b, right? Times x plus product. That means a times b. Correct? So that is the sum and product form of our equation. Do you see that? So it's kind of simple to see it in this fashion, and it helps us to do many examples. So we can take a few examples now. So we can practice finding the product of, let's say, x plus 3 times x plus 1 equals to what? X plus 4 times x plus 5 is equal to what? X plus 9 times x plus 2 equals to what? So you can use this method and write down the results. So in each case, when you multiply, you get x square as the first term. Is that clear? The second term with the x is what? With the x, it is the sum of a and b. That means 3 plus 1, which is 4. Right? So to add these two, 4 plus 5 is 9, and 9 plus 2 is 11. Correct? So you get the sum, and the third part is the product of these two. So that is to say, we have 3 times 1 as 3, 4 times 5 as 20, 9 times 2 as 18. So in this fashion, you could easily write down the expanded form. So this is called the expanded form. Correct? So very easily you can find expanded form. So let me give you practice questions. X plus 6 times x plus 7 equals to what? And x plus 1 times x plus 10 equals to what? Correct? So these are two examples for you. We'll take numbers with negative and same numbers also very soon. Now, here are a few practice questions for you. So we have three examples. First one, find the product x plus 3 times x plus 4. Second, evaluate 103 times 105. And question 3 is, write trinomial for this given factor x square plus a times x square plus 2. Okay, and let me add up question number 4 for you, which is, what is x plus a plus b whole square equals to? Correct? So I'm just adding one more for you. Okay. Now the first few are very easy. Find product. You can write this as x square plus sum. 4 plus 3 is 7. X plus product. 4 times 3 is 12. Perfect. How will you do 103 times 105? Well, one way is I could write this as 100 plus 3 and 100 plus 5. Now we can multiply 100 and 100. So we get 100 and 100. Then we can multiply 100 by 5 plus 3, 8. So we get 800. And then we have to just multiply 5 and 3, 15. And so we get our result, right? So we have 815, so 10815 as our answer. Do you see that? So that is how you do it. Now, let us do this one where we have x squared this time. Earlier we had x. So the only difference is this becomes square of whatever it is. So here what we get is, let's do this first. So we get x to the power of 4, so 2 plus 2, right? So instead of x, we are getting x squared, that is all. Now we have to add a and 2. So we get a plus 2 times x squared and plus 2a. Do you see that? So it's kind of tricky, slightly different from the normal ones, but this is what you get. Okay. Now the last expression here is x plus a plus b whole square. You have to do this part. How do we do it? Well, one way which I could share with you is to make a rectangle. So we'll do it in a different way. So let's say we have this rectangle. Okay. So let's say this is x for us. And then we have a and b. Let's say this is a and this is b. So what I'm trying to say here is that this is x for us, this is a for us, and this is b for us. Okay. Now we are doing x plus a plus b. Now, and we are squaring it. Okay. So that means this side should have been of same length. I have drawn it longer. That's a big problem. I should have drawn it same length. Okay. But anyway, what we will do here is that we'll say, let this be x for us. And then we have a and b, right? So a is slightly bigger than b, right? So on this side also, I'm taking x, a and b. Is that okay? So if I do this, you see I get 3 squares here. So this one is what? X times x is x squared. A times a is a squared. And b times b is b squared. Perfect. So in a way, I could write that x plus a plus b whole square is equal to x square plus a square plus b square. Okay. Now what are these? Now here I get x times a. Let me write down. So this I will write as, let me use a different ink. So we'll write ax here, right? Ax. This is bx. Okay. This is a times b. This is also ax. and this is bx. So we have 2ax, do you see that? And 2bx, right? And we also have 2ab. So after this, we get plus 2ax plus 2bx plus 2ab. Do you see that? So that is how you could expand it. So x plus a plus b whole square will be x square plus a square plus b square. Does it make sense to you? Correct? So that is how you could actually expand the given term or polynomial. And this is a good model. So from this model, you could see very easily how it could be expanded. Correct? Now in the next video, we'll take up the case when x plus a and x minus b type of terms, or when a equals to b. So those cases we'll take up in the next video. I hope that makes sense. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.